Welcome to qnawire.
In this problem on the topic of the first law of thermodynamics, we want to know why the following situation is impossible. A group of campers awake at 8:30 a.m. and they use a solar cooker in order to heat water. Now, during the day, the maximum solar intensity that reaches the Earth's surface at the cooker's location is 600 watts per square meter. And if the cooker faces the sun and has a face diameter of 0.6 meter, and only 40% of the incident energy is transferred to the 1.5 liters of water, which is in an open container, initially at 20 degrees Celsius. We want to know if the water would come to a boil and the campers can enjoy their coffee before hiking 10 miles and returning before noon. Now, the time interval that is required to boil the water is related to the solar power absorbed by the water and the energy transfer, TER. So this time interval, delta T, is equal to the total energy required divided by the solar power, P. And the energy transfer that is required, TER, is equal to MC delta T. We also know that the solar power, P, is equal to Fi times the surface area A, which is equal to F times I times the circular surface area, d squared over 4, where d is the diameter of the cooker's face. And so we can write this as 1 over 4 pi d squared F times I. If we combine all of these equations, we get this time required, delta T, to be MC times the change in temperature, delta capital T, over 1/4 times pi d squared F times I, which simplifies into 4 MC delta T divided by pi d squared F times I. So if we substitute values into this equation using the optimum values, we have this to be 4 times the mass of water, 1.5 kg, times the heat capacity of water, 4,186 joules per kg degrees Celsius, times a temperature change for the water to boil, which will be 100 minus 20, which is 80 degrees Celsius. All of this divided by pi times the square of the diameter, which is 0.6 meters, and that's squared, times the efficiency of 40%, or 0.4, times the intensity of 600 watts per square meter. Calculating this gives us a time to boil the water to be 7.4 times 10 to the power 3 seconds. And this is 2.06 hours. Now, if we include setup time and coffee brewing time, then this time interval nears 2.5 hours. Now, in the morning, the solar intensity is also not the maximum amount, which occurs later in the day. And so the reduced intensity in the morning will increase the time interval even further. Furthermore, we have not included the energy transfer necessary to raise the temperature of the container in which the water resides. All of these considerations will push the required time interval even higher, and so most of the morning will be used in making coffee, and there is no time left for a morning hike.